Assalamualaikum. My name is Muhammad Rusyaidi bin Sham. My matric number is 2021299154. The first subtopic I will present is current and battery. First, we must take a look at this circuit. Whenever the switch is on, the light bulbs would turn on and shine brightly. But if I take this certain item out from the circuit, nothing will happen to the light bulb. How can this be? So, we will learn about current and battery. What is battery? It is a device that stores chemical energy which converts it to electrical energy that can be used as a source of power. Looking at the picture of the battery here, we can see both ends of the battery has positive and negative terminal for current to flow through the battery. The battery also has insulation wrapped around its container to prevent sparks that could be a potential fire hazard. When the battery is added to the circuit, the current would then start to move around the circuit. These currents would move from positive terminal to negative terminal. Moving on to the current, the definition of current is the rate of flow of charge through conductor. From what we can see from this diagram, the conventional current would flow from positive terminal to negative terminal. However, the electron flow would be opposite direction of current because it acts as a charge carrier for current and has negative charge which flows from negative terminal to positive terminal. The formula for current would be I equals to Q per T, where Q would be coulomb and T would be seconds. The SI unit for the current is A ampere. To find coulomb in the formula, we would need Q equals to Ne, where N is the number of electron and E is the charge of electron. Now we know why the light bulb would turn on in the circuit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azidah binti Abdul Aziz. My matric number is 2021289502 and I'm from AS120. For my part, I will presenting about Ohm's law, resistor and resistance. The definition of Ohm's law is the current I in a wire is proportional to the potential difference V between its end. The formula that we use in this topic is V equal to IR. Next, the graph. For figure A, it is a straight line graph. Usually, it is for metal conductor that obey Ohm's law. For figure B, it's a curved line graph. For a non-ohmic device, or for example, semiconductor. This is the example of this topic. A small flashlight bulb draw 300 mA from its 1.5 volt battery. Question A, what is the resistance of the bulb? For question B, if the battery become weak and the voltage drop to 1.2 volt, how would the current change? For question A, the I given is 300 milliampere. To get ampere, we need to multiply 300 with 10 power of negative 3. Next, the V given is 1.5. So we can use the formula V equal to IR. V is 1.5 equal to I, which is 300 multiplied by 10 power of negative 3 and multiply with R. To get R, we need to divide 1.5 with 310 power of negative 3. As a result, we will get R equal to 5 ohm. For question B, the voltage was decreased to 1.2 volt and the R is 5 ohm, so we need to find the I. We will use the same formula, which is V equal to IR. V equal to 1.2 volt equal to I multiplied by 5. To get I, we need to divide 1.2 with 5. So, as a result, we will get 0.24 ampere. Next, resistor and resistance. Its function is to block the flow of current. The SI unit is ohm. There are two symbols. The first one is fixed resistor and the second one is adjustable resistor. The formula that we use is R equal to V over I. It is from the formula V equal to IR. There is two types of circuit, which is series and parallel. Next, the color chart. In this chart, there is color, first band, second band, third band, multiplier and tolerance. Referring to the figure on the table, there are 4 strips of color. The first one is green, blue, yellow and gold. The green one is first band, which is value of 5. Second is second band, blue, which is value of 6. The third one is not a third band, but actually a multiplier. Its value 10 kilo ohm. We need to multiply the value of green and blue strip with 10 kilo ohm, which is we will get 560 kilo ohm. Last, the tolerance strip is in gold, which is value plus minus 5%. The total value of resistor is 560 kilo ohm plus minus 5%. Next, the circuit. There is two circuit, which is series and parallel. For series circuit, it means all components are connected end to end to form a single path for current flow. For parallel, is circuit with 2 or more paths for the current to flow. Next, the formula that we use for both circuit. For series circuit, we use formula V equal to VI plus V2 plus V3. But for parallel circuit, we use formula V equal to VI equal to V2 equal to V3. Next, to find I, in series circuit, we use formula I equal to I1 equal to I2 equal to I3. For parallel circuit, we use formula I equal to I1 plus I2 plus I3. To find R, in series circuit, we use formula R equal to R1 plus R2 plus R3. But for parallel circuit, we use formula 1 over R equal to 1 over Ri plus 1 over R2 plus 1 over R3. Lastly, to find V, in series circuit, we use formula V1 equal to IR1. But for parallel circuit, we use formula V. For parallel circuit, we use formula V equal to I1 R1. That's all from me. I will pass this presentation to my other member. Thank you.
Assalamualaikum. My name is Puteri Aini Syamimi binti Rashid. My ID number is 2021242618. Now I will be presenting about resistivity, electric power, electrical meters, ammeter, voltmeter, and lastly multimeter. So first, resistivity. What is resistivity? Resistivity is the resistance of a wire is directly proportional to its length and inversely proportional to its cross-sectional area. This is the formula of resistivity.
Next, this table shows the resistivity and temperature coefficient at 20 degrees Celsius. For the material, we have conductors, semiconductor, and insulators.
So the resistivity is increases with the temperature, which is P temperature is equal to P naught, 1 plus alpha, T minus T naught, whereas P naught is resistivity at some reference temperature, P temperature is resistivity at temperature, alpha is temperature coefficient of resistivity, and also conductivity, which is 1 over P. Next, electric power. What is electric power? Electric power is energy transformed per unit time. SI unit for power is watt or joule per second. Electric power equation is known as P equal to IV, where I is current and V is the voltage. Or P equal to E over T equal to QV over T. Do you know what you pay for on your electric bill is not power, but energy, the power consumption multiplied by the time. We have been measuring energy in joules, but the electric company measures it in kilowatt hours, which is 1 kilowatt hours is equal to 1000 watt times 3600 seconds equal to 3.6 times 10 to the power of 6 joule.
So, for electric power calculation example is, an electric heater draws a steady 15 ampere on a 120 volt line. How much power does it require and how much does it cost per month if it operates 3 hours per day and the electric company charges 9.2 cents per kilowatt hour? So the solution is we need to use P equal to IV formula and we will get 1800 watt. Next, we need to calculate 1800 watt times 3 hours per day times 30 days. And we will get 162 kilowatt hours. Therefore, at 9.2 cents per kilowatt hour, this would cost 15 ringgit.
Next, we will move on to the electrical instruments. Firstly, we have electrical meters. So, electrical meters is a device used to measure the amount of electrical energy in kilowatt usage of a home, buildings or other electrical powered device that use every month. So this is how electrical meters looks like. Ammeter. Ammeter is an instrument for measuring either direct DC or alternating AC electric current in amperes. An ammeter is a galvanometer in parallel with a shunt resistor with flow resistance. This is how ammeter looks like. Next, voltmeter. A voltmeter is an instrument used for measuring electric potential difference between 2 points in an electric circuit. A voltmeter is a galvanometer in series with the resistor with high resistance. And this is how voltmeter looks like. Lastly, a multimeter. A multimeter is a measuring instrument that can measure multiple electrical properties. A typical multimeter can measure voltage, resistance, and current, in which case it also known as a volt-ohm meter, VOM. That's all from us. Thank you very much for your attention.